Topic is law of multiple proportion. What's the law? Before we start the law, there's a question for you. There's a question in your mind might be, we all know that atoms combine chemically to form a compound. Carbon and oxygen, carbon dioxide. Hydrogen and oxygen, water. Carbon, hydrogen and oxygen, glucose. Now the question is, when two elements combine, then only one type of compound is formed. If you are clever, you already know the answer. Because we have just discussed a few minutes ago its answer indirectly. What is the question written that you can see on the screen also? Is it possible two different atoms can combine chemically in number of ways to form number of compounds, different compounds? If yes, then how could it be possible? Okay, so the answer of this question was given by Mr. John Dalton, right? He showed that yes, two elements can combine to form more than one compound. Example just discussed, hydrogen and oxygen. They are combining to form H2O, water, and under different conditions, they may also form H2O2, hydrogen peroxide. Okay? So one thing is clear, that there are the possibilities that two elements, the two same elements, may combine to give different types of compounds. Okay? So he observed something, he observed a trend, he observed a law, and he gave it in the form of law of multiple proportion. If two elements combine to form more than one compound, this statement is a little bit confusing. Before I read this or tell you this statement, let me tell you something on the board. See, what have we just discussed? Hydrogen and oxygen. I hope you can see it easily. They may form H2O, or they may form H2O2. How many hydrogens? 2. How many oxygens? 1. How many hydrogens? 2. How many oxygens? 2. So what have you observed here? Out of these two, the value of hydrogen, the number of hydrogen, the mass of hydrogen is fixed. 2. 2. Whereas if it is fixed, if the first one is fixed, then there's a change in the second one. 1, 2. Okay? I'm supposing if there is another one, then what could be next? H2O3, it's supposed. So just to put some weight, that hydrogen's contribution remains constant, whereas the contribution, the mass, the value, the quantity of the other element changes in whole number ratio. Okay? Another example. What is that example? See. Carbon and oxygen can combine to form carbon monoxide or carbon dioxide. So can you guess which element is in fixed ratio and which element ratio is changing? Yes, carbon is fixed, 1:1. How many carbons? 1. How many oxygens? 1. So the ratio is 1:1. 1:2. If there is another one, supposed it should be 1:4, 1:3. If there is another one like CO4, it's 1:4. So what have you observed here? The quantity, the mass, the contribution of one of the element is fixed, whereas the other element is participating, in whole number ratio. 1, 2, 3. All right? So here comes the law. When two elements combine to form two or more than different chemical compounds, then the masses of one of the element, like we have oxygen over here, then the masses of one of the elements which combine with a fixed mass of the other, like carbon, like hydrogen. Confused? No problem. You will understand it easily. If you understand it 50%, it's okay. Okay, so what about that element which is combined, whose value is changing? That bears a simple ratio to one another. Remember, two elements forming different compounds. Mass of the one element will be fixed. Mass of the second element will change in whole number ratio, not in fractions. Another example from your book, nitrogen and oxygen. When they combine under different conditions, they form different compounds. A series of 5 compounds which are included in our syllabus. The first one is NO, N2O. Now take it as an assignment. N2, what is the mass of nitrogen? 14. How many nitrogens? 2. 14 twos are 28. So in the first column is written mass of nitrogen 28. O, in the next column is written 16. Just below it, NO, what is the mass of nitrogen? 14. Is there, because there is only one nitrogen. And what is the mass of oxygen? 16. 14 and 16. If you multiply it by 2, look at the screen. We are multiplying by the same value. So overall there will be no net change at all. So we can write it like this. See the third one, N2O3. N2 means 14 mass of a nitrogen, 2 nitrogen are there, 14 to the 28. Then oxygen 16 is the 48. Then the next one, all right. So you can see from nitrogen's column that the mass of nitrogen is constant, whereas the mass of oxygen is changing in simple whole number ratio, 16, 32, 48, 64, etc. All right. Now, or if you want to simplify it, you can see in the next 2 columns. So in these columns, the mass of nitrogen is divided by 2, it changes into 14. In the next one, dividing by 16, 16 to the 16, 16 to the 32, 16 to the, so we get the last one. So you can see in the last 2 columns, the mass of nitrogen is fixed, whereas the mass of oxygen is in simple whole number ratio. All right. So nothing so much explanation in it, just give 2 or 3 examples.